this video is going to be the power rule. So the power rule tells us that if we're taking a function that is x to the nth power, where n is some rational number, example, x to the fifth, okay? If we want to take the derivative of that, as long as our n is a rational number, so this could be 5, it could be 2/3, it doesn't matter, as long as it's a rational number, then we're going to say that the derivative of this is going to be n times x to the n minus 1. And for it to be differentiable, n has to be a number such that x to the n minus 1 is defined, right? This has to be defined on the interval containing 0. Why? Because that's where we're taking the limit. Now, x to the fifth, what this means is we're just going to take the exponent, bring it out front, and decrease the exponent by 1. So bring the 5 out front, so we have 5, then decrease the 5 by 1, and we have 5x to the fourth. There's the derivative. Here, we're going to bring the 2/3 out front, so we've got 2/3 x. We're going to subtract 1, so 2/3 minus 1, which is 2/3 minus 3/3, is negative 1/3, which will give us 2 over 3x to the 1/3. So, one of the most important general derivatives is the derivative of just x. And of course, we can understand that that has a 1, so we'll bring the 1 out front, 1x, decrease it by 1. You got x to the 0, which also is 1, so it's just 1 times 1, which is just 1. So basically, you're saying that the derivative of just x is 1. And this makes sense because we know that the derivative is the tangent line, or the slope of the tangent line. We know that the slope of this line is 1, and that every point is its own point of tangency, right? So it makes sense that if we're talking about a linear function, it's just going to be whatever the slope is. Examples. Bring the 3 out front, 3x, decrease it by 1. Here, now this is an interesting one, because here we've got the cube root of x. I don't know, I don't have a rule for doing roots, but I do know that I can write a root as a rational exponent, right? The cube root is 1/3. So I'm going to bring the 1/3 out front. I'm going to subtract 1 from 1/3, right? 1/3 minus 1 is negative 2/3. So I have the 1/3 x to the negative 2/3, put it down in the denominator. There's a lot of algebra that's going to be going on in this chapter. Next one, y equals 1 over x squared. Not in the form that I want, right? I need to have this as x to some power. Well, I can just bring this up and make the exponent negative. Now I'll multiply the negative 2 out front. X, decrease it by 1. Remember, what's negative 2 minus 1? That's negative 3. Don't tell me that that's negative 1. So we wind up with negative 2 over x cubed. Now remember, in that last example, before we differentiated it, we had to rewrite it. And this is going to be the first step in a lot of differentiation problems, right? You start with what you're given, you transition over to putting it into a form, and then we differentiate it, and then lastly, we simplify. So there's only one, this is algebra, this is the only calculus, this differentiate, right? We got to do algebra again at the end. So we make sure that we write this, that in English terms, the power rule is just bring the exponent out front and then decrease the exponent by 1. That's all there is to it. So if you have any questions about the power rule, shoot me a reminder or ask a question in class.